does the world work at its most fundamental? Can we human beings penetrate the deepest secrets of the world? What does most fundamental mean? It means one can look no further. It means it is impossible, even in principle, to go further. It means explanatory bedrock. What's down there? The laws of fundamental physics, quantum mechanics, perhaps string theory below that, perhaps a final theory of everything, the holy grail of science. I see a challenge to this model of how the world works. It's called Strong Emergence, and it claims that each level of the hierarchy of the sciences, from physics to chemistry to biology to psychology, has its own special laws. Is strong emergence a deep secret mechanism by which the world conducts its business? What would strong emergence mean? I'm Robert Lawrence Kuhn, and closer to truth is my journey to find out. How can strong emergence make such a startling claim? That those special laws in the various sciences, particularly in biology, cannot be completely reduced to or fully explained by physics, not even by that final theory of everything. To discern strong emergence, is it real? How could it work? I've been looking to meet one of its leading proponents, the distinguished mathematician and cosmologist George Ellis. George lives in South Africa, so when I hear he's attending a conference in Crete, I also make plans to attend. As mesmerizing seascapes emerge at the interface of sea and shore, I wonder, is emergence mere metaphor? I'd spoken with George Ellis years before. Now I'm ready to talk strong emergence.
George, the claim that has been growing is that in order to explain how everything works, you need this concept of emergence.
Okay, well, let's ask the following question. If we knew everything about what was the state of the universe at the time of the last scattering of the cosmic microwave background from atom, which is basically 14 billion years ago, could you predict what you and I are saying to each other today from that data?
Right.
Some of the strong physicalists believe that that would be the case. And I think it's absolutely clear that there isn't remotely possible this would be the case, because the fluctuations on the surface of last scattering, if you believe standard cosmology, are random Gaussian fluctuations. Right. Now, out of that, emergence has taken place over time of animals. Human beings are able to think, and human beings then can discuss and produce books like Einstein's theory of relativity, Darwin's book on the origin of the species. Okay. Now, those books contain logical argumentation. There is no way that that logical argumentation was implied in any sense by that data on the cosmic microwave background surface. Something has happened between there and there which has led to that logical argumentation appearing in the real world, which it undoubtedly has done.
On its surface, that's correct. Well, what I can do is I can show an evolutionary picture, and then it would develop the nervous system and the brain, and then you have interactions between brains and communities, and I can give a story.
Yes, but the physics does not come into that story in any way except facilitating. What you're bringing in a Darwinian picture. No physics book has got Darwin's law as a law of physics. No physics books has got the Hodgkin-Huxley equations as a law of physics. They are emergent laws.
But those rules or laws or understandings came out of a mechanism of the brain that somebody came up with. And in some ultimate analytical sense, you could describe how those ideas came in terms of something in the physical world. Unless the claim is that at some levels, there is something that is absolutely non-reducible to the physical.
The claim is that through some of the processes you indicated, many of which are not physical, although they're allowed by the physics, brains came into being which are able to carry out logical argumentation as an argumentation at the psychological level. And that argumentation is what leads to, for instance, e to the I pi plus 1 is equal to 0 being written down on a piece of paper. The physics knows absolutely nothing about that. You have to have the emergence of the possibility of logical argumentation to take place. That logical argumentation then has the possibility of controlling what appears on the piece of paper.
But you're not requiring anything of a non-physical nature here at this point, or are you?
I am. An idea is a non-physical thing.
Okay.
An idea is realized in the brain, but the idea itself is not a physical thing.
Oh, okay.
Now, everything we see around us here, basically except for the trees, was designed by the human mind.
Right.
So the mind is causally effective and thoughts are causally effective, but a thought is not a physical thing. It's realized in a physical way, but it is not of itself a physical thing.
The idea exists and it has its own validity, but it is only realized because of the physical things going on below. I mean, if there's nothing else, unless you're saying that the laws of physics, when they get to a certain level, create things that in principle can never be understood by the microphysics alone.
Well, it can't be understood. You can't understand e to the I pi plus 1 is equal to 0 in terms of Maxwell's equation interacting electrons. I think that's pretty obvious. You can't understand it at that level.
You can't understand that at that level. That's right, but ultimately that's the only way it's realized in terms of...
That is the way it's realized, yes. So you've got multiple levels. You've got the atomic level, you've got the molecular level, you've got the systems level. All of these are simultaneously, causation is taking place simultaneously in all of them in such a way that the logical thing can be worked out, but it's the logic which is driving what happens. It's the physics which enables it to happen, but the logic is deciding the outcome.
So you have what would be downward causation.
Downward realization is my new.
Realization. So what's the difference between causation and realization? You didn't like my word causation.
I've been persuaded recently, different from what I've written about before, that causation is always horizontal, emergence is vertical, and realization is downward.
Oh yeah, that I can understand that. I'm just trying to think, does that get me where you want to get me?
Well, what is useful as a computer is an analog. And when a computer, for instance, sorts a list of names, you feed in a program at the top, and an algorithm is changed down through a series of virtual machines to the bottom level by compilers and interpreters.
And that's the machine language at the
bottom. Machine language it does it, and then it goes up again. And what you fed in at the top results in the list being printed out. The electrons flowing through the gates enable it to happen, but it's the algorithm which has decided what will in fact happen.
But the algorithm is represented ultimately in terms of the transistors and
correct. And at this level, it's the law of its Maxwell's equations and Newton's equations at this level, but at this level it is the logic of the algorithm which is deciding what will happen at that level, and ultimately it's that which decides which electrons will flow through which gates at the bottom level. It's the top level decides what will be done and the lower levels carry out the work.
So let me ask this question. We know the H2O is water. If I gave you some gas of hydrogen, gas of oxygen and hydrogen, could you ever predict that if you got a lot of it together, it would be wet?
No, the answer is no, you can't. This is one of the problems with which...
Oh, okay, so I think there are people who say you can.
Well, all right, let me step back a little bit.
When you know that the angle between the hydrogen and the oxygen, then you can put a lot together, you can see how they would slip and how wetness could occur.
There is a great problem in deriving the macro properties of waters from the micro properties, but let me make the following statement. By the time you've done that, the hydrogen atom no longer exists as a hydrogen atom. It only exists as a water molecule. So the lower level no longer exists as the individual entities. They've got incorporated in higher level entities.
Okay, but if you knew everything about the hydrogen and the oxygen, you should be able to predict the wetness of water if you have it in groups.
You should. In the case of water, in principle, absolutely, you can do that.
So the question is the water example different than your other examples?
Absolutely, because in the other cases, there's logical stuff going on at that level. Well, let me go back to that computer example. Exactly the same logic gets rewritten at each of those levels. It was written in Fortran, it gets rewritten in Java, it gets rewritten in assembly, gets rewritten in machine language. Those levels. Then it gets incorporated into physical systems. The logic is still the thing that is driving everything. And the logic does get embodied in the lower level structures. They are realizing it, but the thing that is driving it is an abstract entity, the logic.
This is Strong Emergence in its full-throated defense. George is its apostle. I learned to distinguish strong emergence from simple or weak emergence. The latter is the idea that radically different properties in science can, with deeper knowledge of the underlying physics, be explained, like the wetness of water. Everyone signs on to simple or weak emergence. It's not controversial. But strong emergence would be an astonishing thing, utterly transformative, a new radical way of how the world works. Could human logic at the highest macro level in our minds drive the physics at the lowest micro level in our brains, even though human logic itself is composed of nothing but that same microphysics in our brains? It sounds circular, mysterious. Yet I'd be hard-pressed to name a more axial question in the physical world. That's why I subject strong emergence to strong critique. And here at the Crete Conference, I have no trouble finding strong critics. I begin with a philosopher of science, an expert on the foundations of physics, David Albert.
David, you talk about the laws of physics being such that that is all the science that you need in an ultimate sense. Mm-hmm. Now, that is directly contradictory to what I perceive as a growing interest in the concept of emergence in what's so-called a strong way, which means to me that in principle you can't explain certain things that happen based on reductionism to physics.
Right. First of all, I don't at all want to be in the position of claiming that I know what the answer is here. I don't. What I do feel strongly is that, reports of the demise of the possibility of reducing everything to physics have again and again and again been greatly and hyperbolically exaggerated in discussions of the foundations of physics. I think that the idea of the possibility of producing a sort of fundamental mechanical explanation of everything is in all sorts of ways terrifying, okay? That in some deep sense, there isn't an important distinction between us and rocks. But we have this physical project that started out by trying to explain rocks and was this unbelievable, fantastic success, applying the same methods again and again and again to more and more complicated systems. So, to the extent that I have a position on this, it's not a position on how it ought to come out, okay? It's a position on what the most interesting course to pursue through this is. And yes, I think that a sort of idea that the world can potentially be reduced to a set of fundamental mechanical phenomena in order to defend the sanctity of human life or something like that, the specialness of consciousness. The death of this project has been announced, and those announcements have always turned out to be premature.
Now, when you're using the word mechanical, you mean in all the sophistication of
all the sophistication, but I mean, once upon a time, quantum mechanics was thought to be fundamentally incompatible with claims that there's a real world out there that can be described in full detail. I would say the most prominent of the premature announcements of the death of mechanical explanations in the world was what accompanied the development of quantum mechanics. We had figures like Bohr and Heisenberg and so on, who were announcing the death of attempts to understand the world deterministically. One of the few prominent voices resisting this at the time was Einstein, who by the time of his death was widely considered to have sort of lost touch with the latest developments in physics. Nowadays, after another 50 or 60 years of reflection on this, most serious investigators of the foundations of quantum mechanics think that it was Einstein who won that argument and not Bohr. And the kinds of demands that Einstein was making for a realistic account of the world, for a mechanistic account of the world, turn out to be much more possible even in the context of quantum mechanics.
Let me tell you a problem I have in understanding. There are a host of really top scientists who are non-theistic and, in fact, non-dualistic. They believe only in the physical world. but yet are committed to the concept of so-called strong emergence,
Yes.
which means that in principle,
Yes.
it is impossible forever to be able to explain certain laws or activities at higher levels
Right.
of biology or chemistry
Right.
or society or
Right.
whatever in terms of the fundamental. What would be a law at a higher level that's only, because they have the constraint, it's only composed of the physics,
Right.
and yet it's impossible in principle to predict it? I don't understand how that could work.
Look, I have to play devil's advocate here because I'm puzzled about how that could be believed as well. There are all kinds of arguments. This is an argument due to a very well-known philosopher named Jerry Fodor. Jerry says, look, take a law of economics. Transfers of money of various kinds have such and such economic effects. Jerry says, look, transfers of money take very different physical forms. Sometimes they're changes in location of pieces of paper. Other times they're electronic events in bank computers. These things have absolutely nothing physical in common with one another. But it's true of every one of them that they increase inflation or something like that. How could that possibly be a physical law or follow from physical laws? Because these events only have something in common when looked at the economic level. They have nothing at all in common when looked at the physical level.
I understand that, but what that means to me is that you then have to encode all of those factors in neural activity, and then those neural activity, it's enormously complicated for sure. It's just an encoding.
I agree
approach.
with that. I think this is just a mistake. Yes, it turns out that there are a whole bunch of very physically different kinds of situations, which nonetheless, once you read it economically in the same economic direction, I think that's what's going on. Now, there are deeper problems about this. There are problems, especially with consciousness, that talking about consciousness as just the motion of these ions in your brain, it just strikes people as apples and oranges,
Right.
okay? And I think there are very deep mysteries there. Maybe the project of reductive physicalism will succeed, or maybe it will fail. This is this powerful, weird, creepy idea, okay, that has made a place for itself in human discourse about the world. For my money, the interesting thing to do with it is drive it as hard as you can.
Dave cannot imagine how strong emergence could drive the underlying physics, which composes whatever generates strong emergence in the first place. I can't either, though I, as Dave, would not find happiness in a purely physicalist, materialist world. Any possibility of transcendence, God, life after death, deep purpose, all out the window. Rejecting strong emergence seems sensible science, but George Ellis alone gives me pause. Could strong emergence be a philosophical problem? I ask a philosopher of science who focuses on big questions of cosmology and mind, Barry Loewer.
Barry, the question, do you need anything but physics? Chemistry, biology, psychology. Is there any laws at that level which are so strongly emergent that they are not predictable by the underlying laws of physics?
Well, I think it's important to distinguish two kinds of questions, what we might call ontological or metaphysical questions on the one hand, and epistemological questions on the other. If you mean that somebody who was told, like Laplace's famous example of the demon who's told the positions and momenta of every particle in the universe, whether the demon could predict all of the regularities found in psychology and so on, I think the answer to that is that the demon could predict where, for example, there would be living beings and where not living beings, where there would be volcanoes and where there would be oceans and so on. But I don't think human beings could do that. The predictions are way, way too complicated. And there are some conceptual issues that get in the way too. So our macroscopic descriptions are inevitably vague. So the epistemological question is, could we actually do biology by just doing physics And the answer is no.
First
On
of all-
the other hand, the metaphysical question, are there regularities or laws of biology which are determined to be what they are from the fundamental physics? I think the answer to that is also no, with a qualification. The qualification is this, that physics is usually described in terms of the fundamental dynamical laws of physics. But I think that something more than the fundamental dynamical laws of physics are part of physics that will be needed in order to even understand how the higher level regularities fit into the lower level physics, because the higher level regularities are generally probabilistic. So I think what one needs, in addition to the fundamental dynamical laws of physics, also what are sometimes thought of as the laws of statistical mechanics. By that, I don't mean the macroscopic laws of statistical mechanics, like the second law of entropy. I mean what Boltzmann introduced to explain the laws of thermodynamics, namely a probability distribution over all the micro states of the universe, and the idea that the state of the universe and very early, what we call early times, at the time of the Big Bang, had very, very tiny entropy. I do think that the package of the low entropy, the probability distribution, and the correct dynamical laws, I think them together are sufficient to, in principle, in Laplace's story, get the patterns and regularities of the higher level stories.
Okay, but at the end of the day, you're saying that all of the regularities, the special kinds and relationships in biology can ultimately, in principle, you can be able to do that. Because strong emergence says you can't.
That's right.
Strong emergence says there's something that happens in some sense in the physical world that as you go up a level, the laws of physics at the lowest levels will in principle not be able to make that jump to that level of biology.
That is right. I think that the weight of reason is on the side of the can make the jump. And here's the reason I'm saying that. That if the jump couldn't be made, then there must be some ways in which the microphysical world evolves which can't be accounted for in terms of microphysics. And the reason for that is that any change in the world at a macroscopic level, let's say that involved biology or psychology, can itself make for a change at the micro level because it could be registered in a computer, for example. And so somebody who took the view of there being this kind of strong emergence would also be taking the view that microphysics is, of its nature, incompletable. Now, that is a view that people have had. For example, Descartes. Descartes held the view that the motions of human bodies, particularly the motions of our bodies when we produce language, cannot be accounted for just in a mechanical means. Now, he didn't know at all the right mechanical means or the right fundamental physical theory, but even in principle, he thought it couldn't be done because he thought that this could only be explained in terms of mentality. I do think that there are explanations in terms of mentality, but I also think that there are explanations in terms of fundamental physics, of why things happen the way they happen. So there's a kind of over-explanation. I don't think of this as over-determination because I don't think of the prior state or situation as, in a fundamental way, determining the later one, in a sense as though causation was something that's fundamental. For those people who think of causation as something that's fundamental, like a fluid which has to be given from one thing to another thing, they might get worried that, look, how could it be that there's a physics causal explanation and also a psychological causal explanation, because there's just too much of this causal fluid. And that seems a bit silly. But
That's
I don't
the
think
over-determination.
I just don't think of causation like that at all. I think of causation as just evolving truths like, look, if the psychological event hadn't occurred, then the physical event wouldn't have occurred. So if you hadn't have thought about elephants, you wouldn't have waved your hand like that. And there's also a physical counterfactual. If such and such had not gone on in your brain, you wouldn't have waved your hand like that. And these are perfectly compatible with each other.
The challenge of strong emergence, to me, is a deep probe of how the world works. Strong emergence is stark and controversial. Laws, regularities, properties that can never be explained by the underlying physics seems mystifying. Never. Not because processes are too complex to know them, but never because we cannot ever know them. How could this be? Top-down realization? But give reductionism a chance. Reductionism is how the world works. all in principle can be explained by physics, although all in practice cannot be. If fundamental physics would be forever not capable of explaining biology or psychology or anything else, if that reduction could not ever be made, then one must conclude that there are mechanisms by which the micro world evolves which cannot be accounted for in terms of physics. Is this a contradiction? Yes, if reality is confined to the physical. But there is no contradiction if one dares venture beyond the known physical. Although I have to be a skeptic, discerning strong emergence brings us closer to truth.
For complete interviews and for further information, please visit closertotruth.com.